Hello, hello, everyone. We're back. We are building um, a custom KEDA scaler. My name is Imad, if you don't know. All right, so today is the third session of us building a custom scaler on KEDA for KEDA on Kubernetes. The last time I think we're gonna have a recap for a couple of minutes. Hopefully it does not go for too long, and then we are going to start building the scaler itself. Let's open KEDA again. So this is our friend, the source code. Last time we went through the source code structure with the folders and the packages and the different scalars and the handlers, and we took an example of I think maybe we went through one of the examples briefly, but what we did is we explained how KEDA works from the inside, specifically around the scaler itself. We said that there are, if we zoom a little bit, we said that there are 4 methods that should be implemented through the scaler interface. The first method was get metrics. Get metrics is the method that will be pulled regularly from KEDA initially inside, and once it scales to put to one pod in the cluster, the horizontal pod autoscaler in Kubernetes will indirectly pull this method through KEDA metrics custom metrics server to get the values regularly. So in our case, like in the example that we mentioned before, if we open the RabbitMQ scaler, it's going to be on the length. If we check the Azure Q scaler, it will be on the Azure Q length, SQS on the SQS length, and so on. So every 15 seconds, I think, or 5 seconds or 15 seconds, the horizontal pod autoscaler will ping KEDA metric server, and then eventually will call get metrics to get the current value of the metrics. It takes a context. The context, at least the last time I checked, it's still being sent as nil. I think in the future it's going to be proper context for the call. Then the metric name, because as a trigger or as a scaler, you might provide metrics for different submetrics. Let's say a metric selector, if you have a specific criteria within the metric to query. Most of the scalars I've checked in KEDA, I don't think they really use the metric selector, so it's just the metric name. And then the return result is the external metric value. The external metric value, if you look at the definition of this guy, you'll see that there is different properties. First of all, that it's an external metric server. External metric value. The metric name. What's the name of the metric we are providing? In Azure Q scalars, it can be the length, the metric labels, the timestamp at which we retrieve this metric. So we keep pulling the queue on RabbitMQ, for example, and each time that we get the length of the queue, so like it's 30 messages or 10 messages or 5 messages, we also say that we got this value at this time. We got this value at this time. We got this value at this time. This is the timestamp. Window in seconds. We'll come back to this. I haven't really spent enough time investigating this one. And then the value itself. The value, you'll see that it's quantity. It's an integer. It's let's increase the volume a bit. Oops. If we go to this guy, you'll see that it's really an integer, because it's a metric that is going to be valued through integer calculations. Like, so we're going to compare it to previous one and do some calculations based on the target that we're trying to achieve. So this was get metrics. Get metrics spec for scaling is when the scaler first created. KEDA needs to create the right HPA, the right horizontal pod autoscaler in Kubernetes. And this function is the one that is called to retrieve the specs that the HPA will have in order for it to know how to query the metrics server for. It will have the if we check it out, the metric source type, which is in our case going to be external source type for most of the time. The object source, pod metric source, we'll come back to this one as well, with the resource metric source. This is what we want, really, the external metric source. It's going to be the metric name, the selector, the target value, and the target average value. In most of the scalars that we have, it's the target average value that we are trying to achieve. So target average value, like let's say let's talk about the RabbitMQ scalar. Let's say that we want for each 10 messages, one pod that consumes these messages to be handled this. If we have 20 messages in the queue, then we want to add 2 pods. This calculation, we do this through this calculation is within the horizontal pod autoscaler itself. If we use the target average value, if we use the target value itself, we just increase the pods regardless of this formula. There's no average between how many messages a pod can handle. The values themselves in the RabbitMQ example are the number of messages. But this value, the integer value, can be anything really. It can be the length of a queue, it can be how many tweets out there, stuff like this. So most of the time we're going to be dealing with target average value. Now, the interesting bit, and we said that the is active is if the scalar is active for like if the scalar wants to decide it needs to shut down for some reason. This is the opportunity where the scalar can do that. And then if it's false, if it returns false for some reason, KEDA will not be able, sorry, it will not pull it. Close, because every time KEDA wants to get the metrics of a metric scalar, it will probably, the scalar itself will consume some resources, open connection to the internet or something, or a database. And in order for the scalar to keep its resources properly, it will call this function to just give it the opportunity to get rid of all the resources or close the connection and stuff like this. This is the interface that we are going to be dealing with. I'd like to cheat from an existing scalar so we can be as fast as possible. So if we check the MQ scalar, I think this is really the best example for us to cheat from. So let's keep it permanent in our editor. And now, since we are in the scalars themselves, we can just create our scalar here. So if I create a new one, file save it as Twitter scalar. Let's assume that we are building Twitter scalar. I think it's going to be wrong like this if we follow the convention. Twitter scalar. Cool. We have our Twitter scalar file. My way of building code, especially in this in these projects, I try to build the very basic functionality that works without any ways of being accurate or fancy or all. I put this all on the side and I just do the simplest thing that works. So even though that this one is called Twitter scalar, for now it just I wanted to just retain a constant integer whenever it was pulled, or it is pulled. So let's start building this thing. The first thing that we want to you know what, before we continue and building the git metrics and all these fancy stuff, let me do what? Let me show you the constructor, because in the scalar itself, let me show you this guy. You can see that there is no there's no constructor usually in concept in Go compared to languages like .NET. So you create a function that creates the struct that's going to be used as the object itself. So in our scalars, the ones that we have, if we check the Robot scalar, you'll see such a method that is says new Robot MQ scalar. We are going to have such a constructor that constructs our object. The thing that we need to keep in mind that this is the only bit that we are going to be hard coding this in the call function. So if I take you to the scale handler, this is where we create the scale or invoke creating the scalars themselves based on the scale objects to create them, yeah, and then go in the scale loop and check them regularly. Here there is a method called getScalar, and you'll see where based on the name of the trigger, we create the right scalar. We will come to the triggers in a bit, but in our case, we can say case Twitter return scalars.new Twitter scalar. We pass the resolved environment. This is the resolved environment for the deployment that is being checked. Maybe we can at some point go back and trace it back to where this is called. And then and this is the trigger metadata. Now you can see that it's complaining because there is no such a constructor. There's no such a method. I saved the file anyway. We're gonna have some errors in in our friend here. Problem as well. We have two problems. Now let's go back to our friend and start copying stuff around. So if I go to the RobotMQ, oops, still getting used to macOS. Let's go to RobotMQ and start stealing stuff. The first thing that we need to steal is the RobotMQ scalar. This is the struct itself, the one that we will bind all these functions to, and we'll have we'll host the metadata and all sort of things. So in our case, we're going to have a type. Let's first of all add the package scalars. We'll come back to the import in a second. Type Twitter scalar. It's a struct, and then we are going to have a metadata property. This metadata property is going to be an address or a pointer to our Twitter meta. Yeah, we can call it Twitter metadata. Of course, it's going to be complaining about it because it does not exist. Oops. We can ignore these two properties because they are very specific to RobotMQ. We are building the very, very, very basic scalar ever. We have the scalar struct. Let's create the Twitter metadata struct. Now, if we check an example of the metadata for RobotMQ, it will give us an understanding what are the metadata we're talking about. Let's take an example. I have the RobotMQ sample. If we open this folder, you'll see that in this consumer, this is the bit that we are interested in. It's a scaled object. Yeah. In the metadata part, this is not the metadata. Yeah, this is the metadata for the object itself. The metadata starts from the triggers. So list of triggers, we have one trigger. This trigger is for the RobotMQ. This is where the scalar knows that it has to invoke this constructor. So it grabs this one Do I have a scalar for RobbitMQ? It will compare in the switch statement. Yes, it will find it. It will create that scalar at that point based on the type. This is where the metadata of the scalar we are trying to achieve. So you can see that there is the queue name. In this example, it's hello. The host, which is another object. It's probably a secret. And queue length. So these things are the metadata that will be read once we create this scaled object. It will be read, and we will fill such properties in here in the metadata. So you can see that it's there's a match between these metadata in the scaled object compared to these metadata properties in this struct. In our case, we are still going very simple. One of the things to explain as well here, that in this example, queue length is considered the target average value. In our case, in this RobbitMQ, what we are saying is that we want that for each 5 metric values, which is 5 messages in the queue, for each 5, one pod will be handling these things. So if the queue length is 25 messages divided by 5, we're going to have a 5 pod scaled to 5 pods. If it's 10, if it's 50, we're going to have 10, we have 10, etc. So in our case, because we want things as simple as possible, let's say we want a number of tweets. Should we say this? Rather than saying number of tweets, let's call this target average metric. Should we call it a target metric? Yes, the target average metric. Let's call it that. In our case, it can be number of tweets, because the reason why I'm going back and forth between giving it a proper property name for the Twitter, let's say like number of tweets per something, because I don't know what or which Twitter API we are going to consume. I haven't decided yet, but we can say that. Let's keep it as is. Target average metric per pod. Yeah. This is going to be an integer, because it's always an integer. Alright, so we have the scalar, we have the metadata. Now we want to steal the methods now. Let's start with the git. Oh. No symbols found. Why, I wonder? Huh? Maybe the compiler is upset and it's refusing to. Let's see what we have done so far. We are in the RobbitMQ. We want to be on this friend. We have added one file, the Twitter scalar, and we have invoked the new constructor. All right, let's. Yeah, no symbols. Let's fix some stuff before we can continue. You know, out of curiosity, let me just comment these. just out of curiosity, and see if things work on this one. Doesn't work yet. Fair enough. I don't know what happened there. Anyway, not a biggie. Let's go back to this, undo this, and save. Now, if we try to build the current package, what's going to happen? Oh, wow. Yeah, I think it's a bigger than that. Let's add the constructor. Oh yeah, let's comment that code first, and then go back. Scale handler. Let me remove the problems. Go back here and comment these lines. Save. Let's go back now to the RobotMQ. Still doesn't work. Let's go to Twitter Scalar, save, and then try to build the current package. Package import. There are much more problems than I thought. Maybe let's see what we can do. Let me make build. Let me make build. So this one does not have anything really. We have commented our friend here, scale handler. So there's nothing interesting there, and we saved it. Then based on that, let's see if we make build. Oh, it's gonna try to create the, it's gonna fail maybe because we don't have a Minikube running, because the build itself creates an image based on the Docker file for the operator, and if Minikube is not running, the build of the image is going to fail because I'm using Minikube as the Docker daemon. I'm using the Docker daemon in Minikube. It might be running actually. I don't know. It's like it's taking its time. I can check that. Minikube status. No, it stopped. So this guy will not work. Let's solve it. Minikube start. Hey, got a coffee. How are you? I'm really sorry that I haven't really noticed your message up until now. I was so consumed in building this thing. I'm sorry. All right, so while Minikube is building, maybe we can reload this window. I don't know, reload window, just in case. And see what happened with Minikube. Yeah. Right, so Minikube has started, but even though that it started, I have to configure the Docker CLI to point to the Docker daemon in the Minikube. So I have to do this dance usually. Minikube Docker environment. This spits out the environment variables to configure the CLI, and then we evaluate them, so it runs. Now if I say Docker PS, it's gonna work. Awesome. Now if we say make, before we do that, Docker images, we have already KEDA with this image. So I think what we'll do is we are going to write it once you make build. You'll see that it's 3 hours here. Let's see what's going to happen if we make build now, if it compiles. For some reason, Visual Studio Code was complaining about everything was there, but it's not a problem, I think. Until that build works, let's see. Let's go back to our Twitter scaler and to our RabbitMQ that we are cheating from. It builds. So if we say Docker images, you can see that it's replaced. Now it's 24 seconds. Right, so back to our thingy. By the way, if you have any comments or questions or interventions, please feel free to jump in. I'm paying more attention to the chat now, I promise. So that would be interesting. Right, so we need to create the constructor. Let's do the constructor first. Okay. I don't know. Do people in Golang call it a constructor? I don't know. Function new scalar. It has to retain, or the parameters it take is resolved environment, and it takes metadata. The authorization params, I think we can skip because we don't have anything to what? We don't have anything to authenticate yet. So maybe you can skip doing that. Metadata, and then of course it retains a scalar with a possibility of an error. We are going to parse the metadata, but I think I'd like to go from bottom up. So this is what is really retaining. It creates the scalar struct, and then creates the metadata of it, embeds it based on parsing the metadata, the map that we retrieved from KEDA. So let's say return the address of Twitter scalar, a new one, and we say the metadata is meta, which is we're gonna create soon. We don't have to create a connection string or a channel. We just need to make sure that we are also retaining nil for the error. Right? It's complaining. Can't use the address of Twitter scalar literal value of type Twitter scalar as scalar value type missing. Yeah, it's KEDA. Ah, yes. This is one of the things, like we are retaining a scalar, which is an interface, but Twitter scalar, we haven't defined all the methods that makes Twitter scalar implement the scalar. So it's gonna be objecting about this. All right, so maybe a change of plans. Let's comment this one. Let's comment it. We'll come back to it. Don't worry. Let's create the other ones. Let's get the metrics for scaling. This is, like I said, the method that we will use, the KEDA will use to create the HPA. It will be, in this case, it will be for the rabbit scalar. We're gonna steal that and make it for the Twitter scalar object. I'd rather copy this because last time when I created it, I missed the metrics. I added some extra S, and I just couldn't find it. It does not take any parameters, but it retains from V to beta 1 the metric spec. I love this a lot. Golang, how it and the Golang language server, it added the import for us directly. Right, so now let's get the guts of it. You can see that it's retaining an array of metric spec or a map. What is it? Is it called? I forgot the Go terminology for that. Let's say we are going to do this exactly. Okay. Copy paste. Oh my god, this is what we do, programmers, don't we? Shame. So we are going now to that. We are creating one instance of the metric spec. Of course, it's external. And then we are going to put the external metric source there. And then this is the RabbitMQ target. This is a string. Oops. This is a string that says external. In our case, we'll say external and then copy as well. But before we forget, because I like to copy these things before we get into the details of this object, I'm gonna put this as an external hard-coded because it provides some clarity for now, and then we will worry about cleaning it later. Right, so this is the source. We are going to add the metric name. Metric name, if we check this constant, is the queue length. It can be really confusing. This is the property in the metadata that will represent the target average value that we are going to be comparing. So this is like the per pod value. It has to have a name in the metadata. This is the name of the property. So in our case, what is it gonna be? I think we agreed on calling it target average something. I think we will rename this at some point later. Metric name. And then, oops, oh, sorry. and then the value itself, the value of that property. So what we will need to do is to go there and add target average value. You can see that it's this fancy integer with the queue length that is coming from the metadata. The metadata here is our friend. So if you go to here, you'll see that we have the metadata here, which is this, the queue name and the queue length. Back. We follow the same procedure. And then it's an integer. We'll come back to that with the remaining of the property so we don't miss ourselves. Okay. And then the value of that is metadata. But in our case is the target average metric per pod. Save. It saves. Beautiful. Now, one method down. Let's see the get metrics. We are going to have a function that is also tied to the Twitter scaler. Get, let's copy again, even though this is very simple. My God, I'll never get used to Mac, am I? Copy this guy. And then the parameters is context, the metric name, because we already agreed that in a trigger itself there can be different metrics, and the selector. This is all not unique to anyone, so we are copying except for the first bracket. So we are pasting like this, and then like that. Cool. Now get metrics, like we said, is the method that's going to be pulled regularly. In our case in RabbitMQ, we are looking at how this is using an internal method to get the messages of the, or like at least to read how many messages in the queue based on the metadata that provided by like the connection string and etc. We are not going to be involved in this one, and of course it's assuming that it will have an error, or we're not gonna have errors because our code is flawless. We're not gonna concern ourselves with a lot of errors checking, at least not in the basic way. Now we are returning a list of the external metrics for the external metric value. Is this? I wonder why. I wonder why it's returning an empty one. Sorry. It's creating an empty one and then appending this to it. There must be a good reason for this. Let's just follow this blindly. Yeah? Don't take me too serious in this one. We are having fun, right? We're doing this for fun. Let's copy this. This is the thing we are absolutely going to retain. Now let's define metric. Metric is an external metric value with special properties. What are these properties? We have the metric name. Why do you think it is not give me the continuation? So I'm expecting that I have a property. Maybe because I didn't save. Let me just save this. And it's going to import the right package. And then maybe now we say, oops, we say metric name. I don't know. Let's just type it ourselves. Metric name. In our case, or in the RabbitMQ is the queue length. In our case, it's the target, the very long name that I decided to use, which is very ugly. Where did it go? This guy. And then the value itself. I have bad feeling about not being given the continuation or the intelligence, the right intelligence. Resource of new quantity. Now this is where I'm going to cheat. Oops. I'm going to retain 10 all the time. This is just to build the very basic scalar before we really make it a scalar that makes sense. Right, so and then the last bit we want to is the timestamp. Save. Do you have any problems? What is missing? Is it like this? What about if we save? Nice. Now that we have saved, it made the lint, and it's good now. So if we say metric name, didn't work. Anyway, it's working now. So we have the metrics, get metrics for scaling. Now there's only two methods that we need to copy. Close, because it's simple. We just need to copy this guy. We are not doing it for the RabbitMQ, so we are going to change it to Twitter scalar. We will have to implement this at some point if we want to be careful about the resources we are using. And the last one is active, yeah, if you remember. Is active is always, in our case, we are going to always be active. Oh, what's happening? So I'm going to always return true, and there's no errors. This is not for the, this is for Twitter scaler. Cool. Any problems? Missing retain. Where am I missing the retain? Retain nil, maybe. Cool. I hope everyone is following. No one has slipped or deserted. All right. If we build, maybe we can come back to this one. Uncomment, undo last commit, shell command. Uh-oh, what is this? What did I do? My shortcuts. Line, remove line comment. That's it. If I save, will it still complain? In meta, yes, there's no meta. We said we are going to, now, this is the interesting part. These are maps of string over string. KEDA will read the scaled object in our, like for example, this guy, it will read it and it will create a string of strings of these, and it will be passed without parsing, without changing into the integer or string or whatever. They're gonna be all strings, and they are you have the chance to navigate through these with these map strings. So in our case, it's a string of a string. Correct. Let's see RabbitMQ again and see what it does. For the new, we said it's the meta is created from parsing the metadata that is being passed. I think because we are not using metadata in any specific way, it inferred the type, so I can still use the map string of a string to define these properties. Anyway, in our metadata, we are not really going to parse it properly. Like we said, we're going to build the very basic one, a very basic scalar. So what I'm gonna think of, my value will be from the metadata passed metadata of this guy. It's going to be a string of this, and then value, and then I'll create a meta. Says what? Yeah, I think it's inferred, but I can say map of a string. Will it be? And this is also, I think, a map of a string. I think I can get away with this. No. So the function should have a comment or exported. This is not a problem. The value not used, it's alright. I think we can get away with this. Like if we go to the scalar handler and we check these guys, if we go to the definition, you can see that find the reference. You can see that the resolved environment is actually a map of a string of a string. So I did some homework. This is why I think I know this. So I think we can safely say that it's map of a string and map of a string of string. Now we are going to say create the metadata, like, because in RabbitMQ Scala you can see that they create the metadata based on the parsing. It just creates one. We are going to inline this. So if we just go there, you can see that it parses these resolved environments and authentication, and then constructs the metadata based on that. We are going to do the same, and we're going to convert this value. So, but we're going to do it inline. So I'm going to say create a metadata for me where Twitter metadata, the target average value is going to be the value. But our value here is still a string, so we are going to convert it from a string to integer. Let's do this and steal this from RabbitMQ again. Can't remember this from the tip of my head. And paste. Are we on track? Yes, we're gonna finish an hour soon. Why is it complaining? Ah, yes. This is one of the interesting things in Golang that I'm still getting used to. The method is retaining two retain values, like a tuple in .NET, what they call it. The object and the error. If we are assigning it like this, then this should be really a tuple itself. But because it's an integer, it's a, like, I don't understand this. In the RabbitMQ, they got it like this, and then they used the value itself. So we can do the same. We can say integer value and error equals, and we take this out and we use the integer value itself, and we get the value from the, we can ignore this one because we are not using it, which is wrong. And this is also wrong. Now we have something. Now we have a constructor, we have the get metrics, we have the get metrics for scaling, and we have the is active, and we have the close. And now we can go to the scale handler again and uncomment our friend here, remove line comment. This way we can make sure that we're alright. Now, if I go and make build in my console, in my terminal, I have no idea where this terminal came from. If I make build, if we make build, I'm really lazy. I should really change the tag from 1.0.0 to my tag. This way it removes any confusion if the image is not in my daemon and tries to pull it from the internet, and then it pulls the official one rather than my one. Okay, now we have an image. So if I say look at images, you can see that we have one that was built only 5 seconds ago. Now we need to deploy our version of KEDA. In order to do this, we go to the charts KEDA. I already showed this in the previous stream. where the KEDA charts moved to this repo. We clone it and then we use it. So what I'm going to say, Helm install, because I've done this before. You can see that we are using the same tags, yeah, and we are saying if not present. So use the image inside. Don't try to pull it from the internet. But will it work? Yes, I hope it's gonna work. And moment of truth. Now let's check our Helm list. We have the Solmite that was deployed just 1 minute ago, and we can get the pods and see that we have an operator that is working fine. Now the ultimate test. Let's create a scaled object and see if our scaler works and scales the deployment based on that. I will cheat again. I'm going to go to this RabbitMQ example. I think we already have it open. You can see that in the example itself, there's the secret that holds the host for the RabbitMQ server. There's the deployment itself, the RabbitMQ consumer. This is what I'm going to steal, and the scaled object that is based on the trigger of the RabbitMQ. What I will do is I'll steal this, and I will steal this and copy them, and then I will change them a little bit. So if I create a new file and we save this as imad.yaml in the handler, package, and scalars. Yeah, of course this is not the right place. I'm just saving it to demonstrate, so we can change this later. It's saved. Now deployment, I'm gonna change the deployment name to be, I think, to RabbitMQ consumer 2, because I already have, according to my memory, I already have a consumer there. So git deployments. We don't actually. Okay, then let's not change it. We have a container of a consumer. Does not really matter what the container is here. We just have a normal container. And the scale object is the one that is important. We are targeting the RabbitMQ consumer deployment above, but here, this is also a very common specs for the scaled object itself. It does not, it's not gonna change between a scalar to another. This is your configuration. But triggers, here we are going to change it to Twitter scalar. This is that matches the string in the switch statement. We don't have a metadata for Q&A, or host or queue links. All what we have in our configuration was Twitter scalar is our friend, this guy. Metadata string. We'll come back to this one, I think, at some point. Right, so this is, we already have, like we are saying, scale this object, scale this deployment using the Twitter scaler, and whenever you for each metric that is retained from the Twitter scaler, for each 5 values we need to instantiate 1 pod, right? Let's make this 2. Now if we go back to our code and deploy our friend, deploy the object. So I think we put it in scalars, so k apply minus file package scalars, correct, package scalars imad.yaml. Awesome, the deployment was created and the scaled object was created. Let's see if we are having, so the consumer deployment was created, the operator was already there, but I was expecting that our container to be scaled to 5 pods, but it's not, which is interesting. Let's see what happened. The way we can see this is like we can check what logs the operator has. So if we say k log, or for example k git pods, we have the operator, k logs of our operator, and enter. It's going to complain because there's 2 containers inside, so we need to supply the value that we're going to say, give me the logs from the container that's called KEDA operator. Yeah, and let's see. Okay, let's feed or pipe this to code to have a better view and see what the problem is. Or maybe we don't have a problem. Failed. Yeah, we have something. Failed. Failed to create new HPA resource. Why failed? The RobotQ consumer. HPA. The error. Error getting scalar for trigger 0. No scalar found for type Twitter scalar. Why? Did we make a typo? This means that the trigger here, this guy, is not matching the key that we used to construct it. Of course, it's Twitter, not Twitter scalar. Remove this guy, save. Deploy again. Apply this again. It's configured. Now k git pods watch. Will it run properly? Still, there is a problem. Yes. Yes. Because we are already retaining 10 as metrics. Imagine that there is a queue for the robot queue, and it's always 10 messages in the queue. This is exactly what we did. We are retaining 10 value, 10, 10, 10, 10. And in our scaled object, in here, we said for each value of 2 of the metrics, create a pod. So 10 divided by 2, we have 5 pods all the time. So if I stop this and I see do this without a watch, you'll see that we are going to have 1, 2, 3, 4, 5. Awesome. I think this is it for tonight. We have built a very basic custom KEDA scaler. I think next time we can make it real. Next time we add Twitter APIs to it with the right configurations for authentication, and rather than just retaining 10, we can read the values from Twitter feed. All right, thank you so much everyone who was part of this. I think at some point I'll upload the videos because I've been recording this as well here. I'll upload them to YouTube, and hopefully people will have a look and enjoy this. Thank you so much, and until next time. Thank you.